I decided to break section 3.7 into two different parts because it was rather gargantuan. And the first part, as you can see, is about implicit differentiation. And the second part, we're going to apply this implicit differentiation in order to find the derivative of inverse functions. So our goal here is to use implicit differentiation to find the derivative of an equation. Well, haven't we been finding derivatives of equations all along? Yes, but this is a very particular kind of equation, which we will see in the warm-up activity. If you notice over here on the assignment, we do have some challenge problems, which are going to be reserved for those BC kids. Okay, so let's take a look at this warm-up activity here. Is the equation y squared equals x a function of x? Okay, come on now. How is this a warm-up question? This is so easy. Of course it's not a function of x. If we were going to graph this thing, let's say, what would it look like? If it was y is equal to x squared, it would look like a parabola. But this is just a sideways parabola, right? So you've got part of it up here, and you've got part of it down here. Just pretend like this little vertex here is nice and smooth. And if you were to solve this equation, like that arrow, okay, if you were to solve this equation for y by taking the square root of both sides, here's what it would look like, of course. Take the square root, and in the course of solving an equation, you take the square root, you should have two answers. You should have a positive and a negative. The square root symbol refers to the principal square root, which is the positive one. So if I want the negative, I got to throw the negative on the outside of it. So this is an example of an implicit equation because it implies two functions of x. Right? We have the positive square root, which is the top branch of this, and then we also have the negative square root, which is the bottom. And so what this lesson is about is trying to find the derivative of this thing. Well, one of the ways to find the derivative, of course, is to write it in its explicit form, or its explicit forms because it has two of them, and take the derivatives individually, which is kind of a pain. We want to be able to directly take the derivative of this equation. And again, that's exactly what this lesson is all about. Right here, objective one, being able to use implicit differentiation to find the derivative of an equation, and specifically it is an implicit equation. The pictures here are taken from this thing called implicit bias or implicit racism. As if you're going to say one of these things or think one of these things, it implies that you are being biased to a particular religion, race, gender, and so on. Just like when we look at our equation, y squared is equal to x, that implies two functions of x. And it doesn't have to be just two, it could be multiple equations. Sometimes they're easy to find the explicit form of, here's the implicit form, and sometimes it's not. The way that you find the explicit form is that you just solve for the variable y. Sometimes, though, that is not either easy or even possible. This one it was, right? Okay, so an implicit equation, the definition is, it's a relation that is defined in terms of one or more functions. Remember that a relation in algebra is just pairing up x's and y's. So this is two different functions where we're doing that thing. Here's the top branch, here's the bottom branch, as we discussed before. Okay, so let's take a look at maybe a couple more of these things. A circle, for example, is an implicit equation. You've got the top half of that circle, this semicircle, which is the square root of 25 minus x squared, for example, and then the bottom half of our circle, the bottom semicircle, which is the negative square root of 25 minus x squared. All right, how about something a little bit more interesting? Let's take a look at this one. So this one would be pretty easy to solve this one for y in order to find the two explicit equations that make up that, are the two explicit equations that make up that implicit equation. Yeah, that's what I'm trying to say. Okay, so here's another one. You can see the equation over here. Whoa, that's not what I wanted to do. There we go. X cubed plus y cubed is equal to 6xy. This is a particular equation, implicit equation, that is known as the folium of Descartes. Descartes is the guy who is responsible for the coordinate plane, lots of stuff, bringing together geometry and algebra together, also laying the foundation for a lot of stuff in calculus. Folium means leaf, perhaps in French or maybe in Latin or something like that. You can see it's kind of leaf-like. All right, so here are the functions that break this thing down right here. Here's the top one. You can see it would pass the vertical line test. And then the second one and the third one. This one implies three equations or three functions of x. It would be incredibly difficult to get each one of those particular functions. But you know what? As you will see, we won't have to. And so the rest of this lesson is going to be about, like, how do we avoid having to solve for y so we can find the derivative? Can we take the derivative directly?